you are doing well. We are Team Electrical Allieds from NITR-ELE-2023 going to present our communication skill project in which we enacted a TEDx talk on how our brain learn new things by Lara Boyd. Now our team will introduce ourselves.
I am Archit Soni.
I am Ayush.
I'm Naincy Vaishya.
I am Aditya kale.
I am Ashish Kumar Jangid.
First of all, we would like to thank our institute, NITR-ELE-2023 and our communication skill professor, Dr. Sandeep Sarkar sir, for providing a golden learning opportunity.
It provides us exposure, experience and insight on how to create a video with minimum required things to make it effective.
Our team has worked very hard for making this video. Hope you all like it.
We highly appreciate constructive criticisms so that we get to know about the shortcomings of the video and do not repeat them in future. So let's start the video.
Brain research is one of the greatest frontiers in understanding human psychology and also in the consideration of what makes us who we are. And what we knew about the brain is changing at a breathtaking pace. And much of what we thought we knew and understood about the brain turns out to be not true or incomplete. Some of these misconceptions are more obvious than others. For example, we used to think that after childhood, the brain could not change. And another misconception about the brain is that you only use a part of it at any given time and it's silent when you do nothing. Well, this is also untrue. It turns out that even when you are rest and thinking of nothing, your brain is highly active. So it's been advances in technology such as MRI that allow us to make these and many other important discoveries. And perhaps the most exciting, the most interesting and transformative of these discoveries is that every time you learn a new fact or a skill, you change your brain. It's something we call neuroplasticity. So as a little 25 years ago, we thought that after about puberty, the only change that took place in your brain were negatives. The loss of brain cells with aging, the result of damage like a stroke, and then studies began to show remarkable amount of reorganization in adult brain. And the ensuing research has shown us that all of our behavior change our brain, that these changes are not limited by age. It's a good news, right? And in fact, they are taking place at all the time. And very importantly, brain reorganization helps to support recovery after you damage your brain. The key to each of these changes is neuroplasticity. It is a remarkable capacity of brain to adapt and rewire themselves throughout life, enabling us to learn, recover from injuries, and evolve as individuals. This understanding has revolutionized the field of brain research and offers hope for continued advancement in understanding and harnessing the power of human brain.
What does it look like? So your brain can change in three very basic ways to support learning. And the first is chemical. Your brain can increase the amount of or the concentration of this chemical signaling that's taking place between neurons. Because this change can happen rapidly, this supports short-term memory or short-term improvement in the performance of a motor skill. The second way that the brain can change to support learning is by altering its structure. So, during learning, the brain can change the connections between neurons. Here, the physical structure of the brain is actually changing. So, this takes a bit more time. These types of changes are related to long-term memory, the long-term improvement in a motor skill. Let me give you an example of how we all have tried to learn a new motor skill. Maybe by playing a piano, maybe by learning to juggle. We all have had the experience of getting better and better within a single session of practice and thinking, I've got it. And then maybe you return the very next day and all these improvements from the day before are lost. What happened? Well, in short term, your brain was able to increase the chemical signaling between your neurons. But for some reason, those changes did not induce the structural changes that are necessary to support long-term memory. Remember, long-term memories take time. What you see in the short term does not reflect learning. It's these physical changes that are now going to support long-term memories and chemical changes that support short-term memory. Structural change also can lead to integrated networks of brain regions that function together to support learning. And they can also lead to certain brain regions that are important for very specific behaviors to change your structure or to enlarge.
The last way that your brain can support learning is by altering its function. As you use a brain region, it becomes more and more excitable and easy to use again. And as your brain has these areas that increase their excitability, the brain shifts how and when they are activated. With learning, we see the whole new network of brain activity are shifting and changing. So, neuroplasticity is supported by chemical, by structural, and by functional changes. And these are happening across the whole brain that can occur in isolation from one another. But most often, they take place in concert. Together, they support learning and they take place all the time. I just told you how really neuroplastic your brain is. And why can't we learn anything we choose to with this? Why do our kids sometimes fail in school? And why as we age, we tend to forget things? Why don't people fully recover from brain damage? That is what limits and facilitates neuroplasticity. And this is what I study. I specifically study how it relates to recovery from stroke. Recently, stroke dropped from being the third leading cause of death in the United States to be the fourth leading cause of death. Great news, right? But actually, it turns out that the number of people having stroke has not declined. We are just better at keeping people alive after a severe stroke. It turns out to be very difficult to help the brain recover from stroke. And frankly, we have learned to develop effective rehabilitation interventions. The net result of this is that stroke is the leading cause of long-term disability. In adults in the world, individuals with stroke are younger and tending to live longer with that disability. And research from my group actually shows the health-related quality of life of Canadians with stroke has declined. So clearly, we need to be better at keeping people recover from stroke. That is an enormous societal problem, and that is what we are solving.
So, what can be done? One thing is absolutely clear: the best driver of neuroplastic change in your brain is your behavior. The problem is that the dose of behavior, the dose of practice that's required to learn new and relearn old motor skills is very large, and how to effectively deliver this large dose of practice is a very difficult problem. It is also a very expensive problem. So the approach that my research has taken should develop therapies that prime or that prepare the brain to learn. And these have included brain simulations, exercise, and robotics. But through my research, I have realized that major limitation to development therapies that speed recovery from stroke is the pattern of neuroplasticity are highly variable from person to person. As a researcher, variability should drive me crazy. Makes it very difficult to use the statistics, test your data and your ideas. And because of this, medical intervention studies are specifically designed to minimize this variability. But in my research, it is becoming really clear that the most important, the most informative data that you collect is showing this variability. So by studying the brain after stroke, we have learned a lot, and I think these lessons are very valuable in other areas. The first lesson is that the primary driver of change in your brain is your behavior. So there is no neuroplastic drug that you can take. Nothing is more effective than practice at helping you learn. And the bottom line is that you have to do the work. And in fact, my research has shown increased difficulty, increased struggle, if you will, during practice, actually leads to both more learning and greater structural change in the brain. The problem is here that neuroplasticity can work both ways. It can be positive, you can learn something new, and also you can refine a new motor skills.
Second lesson we've learned about the brain is that there is no one-size-fits-all approach to learning. So there is no recipe for learning. Consider the popular belief that it takes 10,000 hours of practice to learn and master a new motor skill. I can assure you it's not that quite simple. For some of us, it's going to take a lot of more practice, and for others, it may take far less. So shaping of a plastic brain is too far unique for there to be any single intervention that's going to work for all of us. This realization has forced us to consider something called personalized medicine. This idea that optimized outcomes, each individual requires their own intervention, and the idea actually comes from the cancer treatments. And here it turns out that genetics are very important in matching certain types of chemotherapy. with specific forms of cancer. My research is showing that this also applies to recovery from stroke. There are certain characteristics of brain structure and function. We call them as biomarkers. These biomarkers are providing to be very helpful and helping us to match specific therapies with individual patients. The data from my lab suggests it's a combination of biomarkers that best predicts neuroplastic changes and patterns of recovery after stroke. And that's not surprising, given how complicated the brain is. But I also think we can consider this concept much broadly, given the unique structure and function of each of our brains. What we've learned about the neuroplasticity after stroke applies to everyone. Behavior that you employ in your everyday life are important. Each of them is changing your brain, and I believe we have to consider not just personalized medicine, but personalized learning. The uniqueness of your brain will affect you, both as a learner and as a teacher. This idea helps us to understand why some children can thrive in traditional education systems and others don't. Why some of us can learn languages easily, and yet others can pick up any sports and